All right, good morning, guys. The next thing that we're going to talk about here is solving inequalities with multiplication and division. So I'm actually going to bump over here for a second to give you guys an example using both positive values. So we think about 3 being less than 5. Like, that's pretty easy for us to comprehend. 3 is less than 5 on the number line. It's closer to 0, all that sort of good jazz. But if I multiply both sides, because we know it's a rule of equalities and inequalities, I can multiply both sides by anything I want as long as I do it to both sides. So let's multiply both of these by -2. That then comes out to be -6. And if I leave this symbol the same, would be less than -10. But this is not true because -6 is higher up on the number line, so it has a higher or greater value. So -6 is actually greater than -10, and this is where the big difference in solving inequalities versus solving equations comes in. When you multiply or divide by a negative value, you have to flip the direction of the inequality symbol. That's the biggest mistake that people make. So if you've paid attention for this 1-minute segment, you should have a leg up. You should avoid some mistakes because that is honestly the only change between solving equations and solving inequalities. So let's dive into this lesson and check out how all of this stuff works. Turn on some calligraphy ink. So here's another example of that, looking at where we compare a negative and a positive to start. So -5 is less than 10, and then we multiply by 3 on both sides. That stays true because they're both positive. So let's set up this example. We got to take our verbal situation and make it mathematical. So take a moment to read this and see if you can set this up as an inequality. Pause the video and come back when you think you have it set up. So when we see that the elephant drinks at least, that means that 70 is the minimum that he drinks. So when he drinks water, it will be more than or equal to 70, because being at least, it could still be 70. So then we want to look at how does the elephant drink? Well, he drinks trunkfuls. So each trunkful of water holds 4 liters. So we can then look at how much he drinks and change that to there's 4 liters of water for every trunkful, and that has to be greater than or equal to 70. So now when we go to solve this inequality, we just divide by 4 on both sides to get the t by itself, and that would give me that t is greater than or equal to. I could break up 60 and say 60 divided by 4 is 15, and then 10 divided by 4 is another 2.5. This should be 17.5, and that would be liters. But just for good measure, let's check. And it is 17.5. So each trunkful has to be at least, this is trunkfuls, not liters. So he needs to drink at least 17.5 trunkfuls. So really, if we were to simplify this, we'd probably say he drinks 18 or more, because half a trunkful would be a little bit awkward. I'm sure it could happen, but it'd just be a little weird. Try the got it completely on your own. Pause the video, come back when you think you have your complete finished solution. If you haven't seen it yet, the big difference here comes from he drinks that much water a week. We want to solve how much he drinks in a day. So when we look at solving for this, we know that this water in a week is really 7 days. So we can change our drinks to 7 days of the mouse drinking is greater than or equal to 0.042. We can then divide that 42 thousandths by 7, and we get that every day he must be drinking greater than or equal to 6 thousandths of a liter. Now that seems really small, but realize a liter is really big. So that water bottle that I always have, that's a liter. So 6 thousandths of that compared to a mouse, you can kind of see how that sizing would make a little bit more sense. So here the multiplication property of inequality multiplying by a negative number. This is exactly what I was talking about at the beginning of the lesson. So when we multiply by a negative number, because it changes the value on each side, it flips a positive value to a negative and a negative value to a positive. Of course my smartboard would do that. we then have to flip the direction of that inequality symbol. So check out this example for more reference on why we do that. And let's flip to the back. So now we have to ask ourselves, what's happening to K or what's happening to G here? I want you guys to fill in the correct symbols over here and then work through the correct process right here. Pause the video, come back when you think you have both of these solved out completely. So for the example involving K here, we see that K is currently being divided by -4. To undo that division, we want to go ahead and multiply by -4 on both sides. Forgot my multiplication symbol right here. When we multiply by the negatives, like an alarm, bells, whistles, should go off inside your head and say, hey, I got to flip that inequality symbol because both of these values are now going to flip to the other side of the number line. And we end up seeing that K must be greater than -84. Since we started with a less than symbol, it had to flip to a greater than, and then it stays as a greater than. If you have yet to solve the G example, go ahead and try that, pause the video, come back when you have your solution. So when we look here at the G example, we see G is being multiplied by -3.8. So to deal with that, we then have to divide on both sides. That will isolate our G on the left-hand side. Because we divided by negative values, this greater than or equal to has to switch to a less than or equal to. And when I look at the division on my right-hand side, I get a -8. So then we can say G is less than or equal to a value of -8. So that means that G will have to be below -8 on the number line. So if you look right here, we're going to be -9, -10, -40, -1,000. Any of those values that fall below -8 on the number line. For this next selection, below each inequality, write the solution with the inequality symbol pointed the correct direction. I really should not have said right. So if you want to change that to correct direction, go ahead and try each of these. I'm going to go through these in order, so pause the video and give yourself a little bit of a challenge. See if you can quickly figure out each of these. Be careful with the sign on your values that you're getting, and be careful with the direction of the inequality symbol. All right, hopefully you tried to solve these out on your own, and we're going to check if I did these correctly. Here on -3a greater than 27, we have to divide by a negative, so the first thing you want to do is write your inequality symbol, flip the other direction. My left-hand side, I get just a, and my right-hand side, a +27 divided by a -3 gets me a value of -9. Moving on to the second one, I hope you can see the blue ink there. There is a division by -3, so we multiply by -3 on both sides. That flips my inequality symbol, so that's the first thing that you want to write down. My left-hand side turns to a. My right-hand side, a -3 times a -3 becomes a +9. Moving on, 3a is less than 27. My 3 is positive, so when I divide, I'm just dividing by a positive value. That does not flip my inequality symbol, so we just get a is less than 9. On my next one, we have a divided by 3, but again, it's just +3. So when we multiply to cancel out the division, that's going to end up giving me 9 on the right-hand side, so a is greater than 9. My last one, we have 3a is less than -27. Even though this 27 is negative, it doesn't matter. We're dividing by a positive value. That inequality symbol stays pointed the same direction, and we get that a is less than -9. Whew. Hopefully those make sense to you. If they don't, please ask a question. If you're here on the day that I'm absent, ask a question to Mr. Hull. Otherwise, move on and check out figuring out the solution to 1/12 of b is less than 1/12. We talked about what we want to do when we have fraction coefficients. So you can either try to remember our rule for what do we do when we have a fraction in the place of the coefficient, how do we cancel that out, or you can think of 1/12 really as being b divided by 12, because that would be a 1/12 of b. So if you think of it like this, that's going to tell you that we want to multiply by 12, but really what we want to do is multiply by the reciprocal of the fraction. Because what if this was like 5/12? Then I wouldn't just be multiplying by 12, I'd be multiplying by 12 over 5. So what we're going to do on both sides here is multiply by 12 over 1 and multiply by 12 over 1. So these 12s on top and bottom cancel, the 1s on top and bottom cancel, and we get just b is less than or equal to, because we multiplied by a positive, doesn't change the direction of my inequality. 1/12 times 12 just gives me 1. So I get that b is less than or equal to a value of positive 1. Try the got it on your own. If you get stuck, come back to the video, but I want you to see if you can set this up as an inequality and solve it out on your own. So the problem that we're faced with here is if half of a number is less than 100. So I've set up half of some unknown number. And you can either put n divided by 2 or half of really just tells me that we're supposed to be multiplying here is less than, so I have my less than symbol, 100. Of course I have my 100. So then I want to figure out, well, if half of a number is less than 100, if I double that half of a number, I'm going to figure out what the value of that number could possibly be. So I double both sides, and I get that n is less than 200. Remember again, we multiplied by a positive, so the direction of my inequality does not change. It stays less than. So we get n is less than 200. That is it for this lesson, guys. So as you can see, the videos only ran about 11 minutes. You've probably paused a little bit, so you should still have class time left. Go ahead and get either a PC, laptop, or a Chromebook if it's available and work on your practice assignment for the rest of the class time. I will take any questions tomorrow, and we're actually going to be doing a slightly alternative activity for the holidays coming up. So I will see you guys when I'm back from my math conference. Have a great day. Thank you very much.